Hi, my name is Greg Rubin, and I'm going to be talking today about an idea I came up with a couple years ago that I call paired pitching. You may have heard of an earlier version of it called tandem pitching or something like that. To kick things off, I want to get everybody in the room involved, so we're going to do a little bit of an experiment. I'm going to give you $30 million each. I'm actually worth like 30 billion or so I'm going to give everybody $30 million, and you can now invest that money in one of two investments. You can invest it in the red pill or the blue pill, and you can't split your money. $30 million in a single investment. Okay, so what are these investments? The blue pill is this. The investment runs from April to October, and you can see the daily returns right there. Now, here's the other investment, the red pill. And the red pill here also runs from April to October, and the daily returns are here. So think for a second about which one you'd rather have for $30 million, and make your choice. Good, okay, so raise your hand if you chose the blue pill, the blue investment. Good, so you just bought the 2012 Atlanta Braves pitching staff. $30 million buys you every pitcher on the staff, and it buys you 94 wins, which places you second in the division. You lost the tie-breaking game, so you didn't actually make the playoffs, but 94 wins is great. You are actually sixth in the ML for runs per batter faced, which is an important stat we'll talk about later. It's kind of a measure of efficiency or effectiveness. And unfortunately, you also bought the most volatile pitching staff in the majors. Now, who bought the red pill, $30 million into the red investment? If you chose the red investment, you just put $30 million into the S&P 500. And from April to October of last year, you made 4% on your money, so about $1 million. You also bought an extremely low volatility portfolio, which is something important that we should talk about for a minute. So, in addition to the returns piece, there's also this issue of volatility, or as a lot of investors call it, risk. Basically, 2008 tells us anything. It's that no two returns are built equal. So no two 94-win baseball teams are the same, and no two 4% return portfolios are the same. When you talk about the element of risk, it changes things dramatically. And that's the essence of the paired pitching model that I'm going to present to you, is the fact that it incorporates this other lever. Now, the balance between return and risk is something that's obviously well known in the investment community. Portfolio managers even have a term ratio to measure the trade-off between return and risk. They call it a Sharpe ratio. All a Sharpe ratio really is it's just a return divided by risk. So for every unit of risk, how much return are you getting? In case you're curious, the S&P from April to October had a Sharpe ratio of 4.5. So for every unit of risk, you got 4.5 units of return. The Atlanta Braves pitching staff, the blue pill investors here, you got a Sharpe ratio of 0.9. So for every unit of risk, you got less than 1 unit of return. So you tell me which is a better investment from an investment standpoint. So let's take this a little further. We can actually plot return and risk on a graph. So here we have return plotted on the y-axis and risk plotted on the x-axis. And here we have a bunch of portfolios of typical investments plotted out. So you have, for example, cash, which is down here, low return, obviously, you're putting it under a mattress, but low risk. Unless you're getting robbed, nothing happens to it. Up on the other end of the spectrum, you have the emerging markets. So that's an investment that has potential for high return, expected high return, but it also comes with a great deal of risk. And you have all sorts of things in between. This line here is called the efficient frontier, and it is a line drawn such that all potential portfolios are encapsulated by it. The universe of potential investable portfolios is down and to the right of the efficient frontier. So, if you're an investor, you're trying to push as far as you can towards that line, right? That I want to move up and to the left. Now, I can do this with pitching staffs. I can plot returns, and in this case we're talking about batters faced per run as the return metric. So let me talk for a second about that. A batter faced per run. So if your batter's face per run is 9, it means that every time through the lineup you give up 1 run. You face 9 batters, you give up 1 run. A number less than that, you do worse. A number higher than that, you're doing better. So that's why we have this on the y-axis. On the x-axis, we have the standard deviation of that metric through the season last year. And we have all the different pitching staffs plotted on this graph. And we have an efficient frontier drawn so that it surrounds every investment. And you can see that 3 teams define the efficient frontier: the Marlins, the Yankees, and the Rays. So what this means is a bunch of things. In particular, it means that if I'm risk averse, if I don't like risk, I'm going to trade you, the Yankees staff, in return for the Marlins staff. So I'm going to give up a little bit of expected return, but I'm going to save a bunch of risk, right? I'm going to reduce my risk considerably. In this case, they're identical investments from a Sharpe ratio standpoint because they offer an equal trade-off between risk and return. Up on the other end here, I have the Rays, so if I don't care about risk, if all I care about is the expected batter's face per run to be high, returns high, then I would trade you either of these pitching staffs for the Rays. I'm getting a considerable amount of risk, but I'm also getting the highest amount of return possible. Good, okay. So now we've talked about that, we can look at what you bought for your $30 million. You bought the Braves pitching staff, the most volatile pitching staff in the majors last year. Has decent returns. There's a few investments that I would prefer above that, lower risk, higher return, but all in all, not a terrible investment from a Sharpe ratio standpoint, except that you had the most volatile pitching staff in the majors. So volatility equals risk from an investment standpoint. Risk in the form of starting pitching takes many forms. It can be injury, it can be leaving a guy in too long. There's a whole host of other risks involved with starting pitching. Those are 2 major ones, and we'll keep that in mind as we go on. In addition to the risk, starting pitching is also inefficient, right? So with the risk comes inefficiency. In 1960, starters faced about 34 batters per start. Nowadays, they face 25, which means that relievers are facing more and more of the game, and thus that may be one reason for this risk that we see, the volatility that we see. The question isn't what's causing the volatility, it's what do we do about it, right? What strategies can we employ so that this number here, 25 batters faced per starter, isn't killing you as a pitching staff? Somehow the market hasn't corrected for this, and so the question I asked myself was, why hasn't the market corrected for this? There's got to be some sort of mechanism you can employ to make your team more efficient, reduce risk, maybe give up a little bit on the return side, but all in all, make a better investment. And what I found was that, as I'm sure many people know, the first time a pitcher faces a batter, the pitcher does pretty well. The second or third time the pitcher faces the batter, he doesn't do nearly as well. And this is an analysis I did that I controlled for a bunch of other factors, and I found that times faced is still statistically a significant effect when it comes to pitching efficiency. The bad news is that no pitcher is immune to this. What you're looking at is what was considered expected to be one of the most devastating and effective 5-man rotations in baseball. And unfortunately what we saw is that the second and third time through the lineup, these guys weren't nearly as effective as they were the first time through. The exception was Joe Blanton, who the Phillies traded away. So the idea behind paired pitching is to reduce the number of times each pitcher faces the lineup a second or third or even fourth time through. If you do that, in theory, you would reduce the number of runs allowed, and you would increase your batter's face per run. Use more pitchers who pitch less. So the idea I had originally is to have 2 pitchers, 2 paired pitchers, each of them face 4 innings, right? So paired pitcher 1, innings 1 through 4, paired pitcher 2, innings 5 through 8. You have a closer for a potential 9th inning. You have 3 bullpen guys in case there's extra innings or a paired pitcher can't go all 4 innings. So in doing so, I can look at past performance because I know what a guy's first 4 innings look like, and I can extrapolate that to say, well, that's what it would be if he came in the 5th inning, right? So now I know what 8 innings of work would look like, and to do the analysis to compare what paired pitching would do compared to the traditional pitching staff. So let's look at a traditional pitching staff. Traditional pitching staff has 5 rotation spots, 7 bullpen guys, and a closer. We know that batters per run allowed for each of those roles. We know the batters per inning for each of those roles on average, and we know the innings per game for each of those roles. And we can do the math, and we see that on average, the traditional pitching staff gives up about 700 runs per season. Now, a paired pitching staff has different roles. They have paired pitchers who each take 4 innings, so that's 8 innings. You have 3 bullpen pitchers who only come in when necessary, and a closer who comes in for a 9th inning. We know these numbers as well, and we can do the math, and we come out to 650 runs allowed, which is a marked improvement over the traditional pitching staff. In fact, it's 49 runs, about 5.5 additional wins on the average if you were to employ the paired pitching staff as I've laid it out. Now, I presented this idea a couple years ago at this conference as a research paper, and I got some great feedback. In particular, one of the scouts said, "There's an issue with this. The aces would never go for this." And I said, "Well, I know, that's fair." And he said, "But no, there's a bigger problem to that. So you remove the aces, now you're left with 5th spot rotational guys, you're left with middle relievers, you're left with minor leaguers you could promote, which is all well and good, saves you money, so on and so forth. The problem is, these guys don't have a perfected third pitch, and you need that third pitch to get through the lineup a second or third time." And I thought, well, that's a significant barrier to this program, to this strategy. I can't teach a guy a third pitch, but what I can do is I can limit the number of times he faces the lineup. So if he can't face the lineup a second time, fine. Instead of 4 innings as the constraint, we'll make it 1 time through the lineup. So instead of paired pitchers, you have lineup pitchers. So a lineup pitcher would come in, face the lineup, get yanked. And this would just recur until the game was over. So in doing that math, you have to assume that there's only one role on the team, a lineup pitcher, and you have 12, maybe 13 lineup pitchers on your pitching staff. And you know the numbers for once through the lineup, so you can do the similar math, and you come up to an additional savings of about 11 runs, which compared to the traditional staff gets you about 7.2 additional wins on the average. In addition, if you go back to my 4-inning model, just for simplicity's sake, you see that you do find you lower risk in the form of injury or potential injury. So a normal rotation spot starts 32 games in a season, throws about 3,100 pitches. A paired pitcher would start about 40 to 42 games and only throw 2,600 pitches, a 500 pitch improvement. In theory, that would reduce strain on the arm, strain on the body, less injury. Now, wouldn't it be nice if there was some empirical evidence? Yes, there would, and in fact there is. On June 19th of last year, the Rockies employed a 75 pitch count constraint on their pitching staff. Now granted, this is a distant cousin to what I'm suggesting, but it's a great piece of empirical evidence that we can test to see what would the effect of any constraint on a pitching staff whose objective it is to reduce the number of times faced through the lineup. What would that look like? So we can look at this, and in fact there was a 5% improvement. Not massive, but a significant improvement from statistical standards. In fact, if they had employed this program through the entire season, they would have saved about 26 additional runs allowed. Granted, you have to control for a number of different factors, the sample size is small, but that's something significant there. And if you look at it from a risk and return profile standpoint, the Rockies do in fact move up and to the left, as I was saying. Up and to the left is the key. So, in conclusion, what am I saying? Well, I'm saying that pitching as it stands right now is inefficient. Teams are spending a lot of money on inefficient pitchers, starters who don't go as far into the game as they used to, and there's a way to improve upon this without doing anything drastic. Being able to use the pitchers you have and even shedding some of the high salary pitchers. Now, unfortunately, you can't just flip a switch, as the Rockies found out. In fact, apparently they're going back to a more standard model of pitching. It's an evolutionary process, right? You can't just flip a switch. You need to build from within, promote the guys that you think would do well in this system, And ultimately, you would end up at a place where you have a completely new-looking system, a pitching staff that is like no others in the majors, and you would be ahead of the game. Unfortunately, if every team did this, there would be no advantage. They would all be, it's a zero-sum game, so they would all be at the level playing field, but the first team to employ this would see a significant improvement in the number of runs allowed, and they would win more games. So thank you very much, and I look forward to any questions you may have.